How do you add or subtract multiple fractions? So how would you evaluate this expression that contains 4 fractions that have to be added and subtracted amongst themselves? So the first thing you'd want to do is you would want to look at every one of these fractions and you would ask yourself, can I reduce that fraction? So look at -1/16. Well, -1/16 has a 1 in the numerator, so this fraction for sure cannot be reduced. What about 3/6? Well, if you take the numerator 3 and you divide it by 3, you're going to get a 1. And if you take the denominator 6 and you divide it by 3, you're going to get a 2. So 3/6 can be reduced to 1/2 or just 1/2. So let's go ahead and do that. So the above expression is equal to -1/16 plus 1/2, where again 1/2 can be reached by dividing the numerator and the denominator by 3, minus 7/5. Can you reduce 7/5? Well, 7 is a prime number, 5 is a prime number, so you cannot reduce this. 7/5 plus 5/18. Can you reduce this? Well, 5 is prime and 18 is not a multiple of 5, so you cannot reduce 5/18. So just write down 5/18. Now, after you've reduced every one of these fractions, you would then ask yourself, can I perform the arithmetic between any set of these fractions? And the answer in this case is no, because every single one of these fractions has a different denominator from all the other fractions. So you cannot directly add or subtract these fractions. So what you're going to have to do is you're going to have to convert every one of these fractions into equivalent fractions that all have the same common denominator. The same common denominator. Now, in this particular case, because we have a large number of fractions, I would recommend converting all of these fractions into equivalent fractions that all have the LCD, or the least common denominator, as their denominator. So you're going to convert every one of these into equivalent fractions that all have the LCD as the denominator. Now, how are you going to find the LCD for such a large group of fractions? Well, I would just use a table method. So let me show you how the table method would work. So just draw yourself a very basic table. So essentially all you need is a left margin and a top margin. Just draw yourself a basic table. And in the left margin here, write down in the first column vertically all of your denominators. So the denominator of the first fraction, 1/16, or rather -1/16, is just 16. The denominator of the second fraction is just 2. The denominator of the third fraction is 5. And the denominator of the fourth fraction is 18. Okay. And now on the left-hand side, I'm just going to write myself a list of the first few prime numbers. So I'm just going to write the first 5 prime numbers. Now, if you can't remember these prime numbers, I have a previous video about how you can easily find the first few prime numbers. So how can you easily find all prime numbers up to a certain size of prime number? So the first 5 prime numbers are just 2, 3, 5, 7, and 11. Okay, and now you're going to ask yourself, are any of these denominators divisible by the first number on your prime number list? So the first number on your prime number list is 2. And now you're asking yourself, are any of these denominators divisible by 2? And if any of them are divisible by 2, go ahead and write 2 in the top margin. So 16. 16 is an even number. 16 is divisible by 2. So at least some of the denominators are divisible by 2. So I'm just going to write 2 in the top margin. Now, under the 2, for every denominator, if that denominator is divisible by 2, write the result of that denominator divided by 2. And if that denominator is not divisible by 2, just go ahead and copy that denominator over. So let me show you how that works. 16 is divisible by 2, and 16 divided by 2 is equal to 8. So write the result of 16 divided by 2, 8. 2 divided by 2 is equal to 1, so write 1. 5, well 5 is not divisible by 2, so just go ahead and copy 5 over. What about 18? 18 divided by 2 is equal to 9, so just copy 9. Okay, now do the same thing. For your rightmost column here, so that the column that contains 8, 1, 5, and 9 in the bottom panel here, ask yourself, are any of these numbers divisible by 2? 8 is an even number, so 8 is divisible by 2. So go ahead and write 2 in the top margin. And now under the 2, do the same thing. For every number, if that number is divisible by 2, write the result. And if that number is not divisible by 2, just copy it over. So 8 divided by 2 is equal to 4. 1 does not divide by 2, so I just copy it. 5 does not divide by 2, so I just copy it. 9 does not divide by 2, so I just copy it. And now do the same thing. Are any of these numbers divisible by 2? Well, 4 is divisible by 2, so I'm just going to write 2 in the top margin. 4 divided by 2 is just equal to 2. 1 does not divide by 2, so just copy it. 5 does not divide by 2, so just copy it. 9 does not divide by 2, so just copy it. Now do the same thing. Are any of these numbers divisible by 2? Well, 2 is divisible by 2, so write a 2. 2 divided by 2 is equal to 1. 1 does not divide by 2, so just copy it. 5 does not divide by 2, so just copy it. And 9 does not divide by 2, so just copy it. Okay, now look at this column over here, 1, 1, 5, 9. Are any of these numbers divisible by 2? Well, the answer is no. Well, if none of these numbers are divisible by 2, go to the next number on your prime number list, on your left side over here, which is 3, and ask yourself, are any of these numbers divisible by 3? Well, the answer is yes, 9 is divisible by 3, so go ahead and write 3 at the top. And do the same thing. So 1 does not divide by 3, so just copy it. 1 does not divide by 3, so just copy it. 5 does not divide by 3, so just copy it. 9 divides by 3, and 9 divided by 3 is just equal to 3. And here I'm just going to extend this table because we're going to need a few more columns. So now do the same thing. Are any of these numbers divisible by 3? Again, we don't have to go back to 2 because we already exhausted all of the 2's in the first 4 rows, or rather first 4 columns over here. So, are any of these numbers in the rightmost column divisible by 3? Well, 3 is divisible by 3, so go ahead and write yourself a 3 in the top margin. And then 1 does not divide by 3, 1 does not divide by 3, 5 does not divide by 3, 3 divided by 3 is equal to 1. Okay, are any of these numbers divisible by 3? No. What about the next number on your prime number list? 5. Are any of these numbers divisible by 5? Yes, 5 is divisible by 5. So go ahead and write 5 in the top margin. And then 1 does not divide by 5, so just write 1. 1 does not divide by 5, so just write 1. 5 divided by 5 is just 1. And 1 does not divide by 5, so just write 1. And once you reach a column of 1s, stop. So once you reach a column of 1s, just stop. And your least or lowest common denominator is just equal to the product of all of the numbers in your top margin. So just 2 times 2 times 2 times 2 times 3 times 3 times 5. Believe it or not, this is your least or lowest common denominator. So what is this number? Well, what is this number? Let's go ahead and copy it down. Our least or lowest common denominator is equal to 2 times 2 times 2 times 2 times 3 times 3 times 5. So what is this equal to? Take the first two 2's, so 2 times 2 is 4, then multiply by 2 times 2 is 4, multiplied by 3 times 3 is 5, and multiplied by 5. Or rather, I was getting ahead of myself. 3 times 3 is obviously 9 times 5. Okay. 4 times 4 is equal to 16. And then 9 times 5 is equal to 45. So what's 16 times 45? Let me just do the arithmetic here in the top margin. So what's 45 times 16? 6 times 5 is 30. 6 times 4 is 24 plus 3 is 27. Add a 0. 1 times 5 is just 5. 1 times 4 is equal to 4. 270 plus 450 is equal to 720. So your least or lowest common denominator is equal to 720. Your least or lowest common denominator for this problem is equal to 720. So now your objective is to take every one of these fractions and convert it into an equivalent fraction that has a denominator of 720, because 720 is your least or lowest common denominator. So I'm just going to take this line up here. And I'm going to write it at the bottom of the page so that we can just work underneath that line. So I'm just writing that line. So we have negative 1 over 16 plus 1 over 2 minus 7 over 5 plus 5 over 18. That's the same line as that line above. And so how are you going to convert every one of these fractions into equivalent fractions that all have the least or lowest common denominator of 720? Well, for the first one, for the first fraction, you're going to have to find out what you're going to have to multiply the denominator by in order to get 720. And whatever that number happens to be, you're going to have to multiply the numerator by that same number. So what is that number? Well, the easiest way to find that number, I'm just going to do a little bit of arithmetic on the side, is to take 720, which is the least or lowest common denominator you're trying to reach, and divide it by 16. So divided by 16. So how many times does 16 fit into 72? 4 times. 4 times 16 is equal to 64. Subtract 8. Drop down to 0. How many times does 16 fit into 80? 5 times. 5 times 16 is equal to 80. Subtract 0. So you're going to have to multiply the numerator and the denominator by 45, because 16 times 45 is equal to 720, and because 45 over 45, so 45 divided by 45 is all equal to 1. So everything you have in this, enclosed in these brackets is equal to 1. And negative 1 over 16 times 1 is still just equal to negative 1 over 16. Okay, so what are you going to do now? Well, to this, you're going to add 1 over 2. 1 over 2 times what? Well, you have to convert this 1 over 2 to an equivalent fraction that also has 720 as the denominator. And this one you can just do in your head. You just have to ask yourself, what do you have to multiply 2 by to get to 720? So essentially, what is 720 divided by 2? Well, 360 is 720 divided by 2. So just multiply the numerator and the denominator by 360. And again, 360 over 360 is equal to 1. So everything you have in these brackets is just equal to 1. Now from this, you're going to want to subtract 7 over 5. And again, we're faced with the same problem. What do we have to multiply 5 by to get to 720? What do we multiply 5 by to get to 720? So essentially, we're asking ourselves, what is 720 divided by 5? So 5 goes into 7 one time. 1 times 5 is equal to 5. Subtract 2, drop down to 2. How many 5s can you fit in 22? Well, you can fit 4. 4 times 5 is equal to 20. Subtract 2, drop down to 0. How many 5s can you fit into 24? 4 times 5 is equal to 20. Subtract 0. So you can fit 144 5s in 720. So you're going to have to multiply the numerator and the denominator of this fraction by 144 in order to get an equivalent fraction that has a denominator of 720. Now to this, we're going to want to add an equivalent fraction for 5 over 18 that has a denominator of 720, except I'm starting to run out of space here, and we really don't need this. This was just a calculation to find out what we had to multiply 16 by in order to get to 720, so we don't actually need this calculation. I'm just going to go ahead and erase it. I'm just going to erase it to get it out of the way. And so to this, you're going to add 5 over 18 times what? Well, again, you have to find out what you have to multiply 18 by to get to 720. So let's go ahead and do that math. So we're asking ourselves, what is 720 divided by 18? And 18 goes into 72 exactly 4 times. 4 times 8 is 32. 4 times 10 is 40. 40 plus 32 is exactly equal to 72. 72 minus 72 is 0. Drop down to 0. 18 goes into 0 times. So you're going to have to multiply the numerator and the denominator by 40, because 18 times 40 gets you 720, and 720 is our least or lowest common denominator. Okay, so now let's go ahead and perform the multiplication for every one of these 4 fractions in order to convert these fractions into equivalent fractions, all of which will have a common denominator. In fact, they all have the least common denominator of 720 as their denominator. So for the first one, negative 1 times 45 is just equal to negative 45. And then we actually don't have to perform multiplication here. We'll know that 16 times 45 is equal to 720 unless we made a mistake. So this is equal to 720. And to this, you're going to add 1 times 360 is equal to 360. And again, 2 times 360, you can do this in your head, but you just know that 2 times 360 is equal to 720. Minus, well, 7 times 144. We might actually have to do this arithmetic somewhere. So let me go ahead and do this in this margin here. So what is 144 times 7? 7 times 4 is 28. 7 times 4 is 28 plus 2 is equal to 30. 7 times 1 is 7 plus 3 is equal to 10. So the answer of what is 144 times 7 is 1008. Is 1008. So here we're going to subtract 1008 over what? Well, 5 times 144, unless we made a mistake, has to be equal to 720, our least or lowest common denominator. And to this, you're going to add, well, 5 times 40, 5 times 4 is 20, add a 0, 200, over, again, 18 times 40 is 720. And so we're almost done here. All we have to do is we just have to perform the arithmetic. So we just have to perform the arithmetic. So in this case, now all of our fractions are converted to equivalent fractions that have the same denominator. In fact, they have the least common denominator, the 720 as their denominator. And so now all we have to do is just add and subtract the numerators as necessary and divide the result by 720. So what is 360 minus 45, or negative 45 plus 360? Well, this is just equal to, so I'm evaluating these two terms first. Negative 45 plus 360 is just equal to 315. Oops, 315 over 720. And from this, you're going to subtract 1008. So negative 1008 plus 200 is just going to be equal to 808 over 720. And so your final answer is just going to be whatever 315 minus 808 is, and 315 minus 808 is exactly equal to negative 493, and your denominator is just going to stay the same at 720. And so this is your final answer.